Experts are increasingly certain that we will one day look back at the era of space exploration and divide it into two distinct periods: before and after the launch of the James Webb Space Telescope (JWST). This perspective is hardly surprising, given the groundbreaking discoveries that the telescope has already made in its short time of operation. The James Webb Space Telescope is the most powerful telescope ever built, and its discoveries have begun to challenge our long-standing understanding of the universe. These findings have revealed that our current models of the cosmos simply do not align with the reality of what is out there, forcing us to re-evaluate everything we thought we knew about the universe's origins and evolution. One of the most striking revelations from the James Webb Space Telescope is the discovery of structures that should not exist according to our traditional understanding of cosmology. Webb has detected a range of cosmic objects that appear much larger and more massive than they should be for their age, based on current theories of cosmic evolution. Specifically, Webb has uncovered structures that formed immediately after the so-called Dark Age of the universe, and these objects seem to be far too large and massive for their early formation period. These findings have led many experts to admit that the current models of the early universe are outdated and that there is still a great deal we need to learn about this confusing era in the history of the cosmos. To understand the significance of these discoveries, it's essential to step back and reflect on the early history of the universe. The vast, star-filled night skies that we see today were once part of a universe that was in absolute darkness. This might seem almost inconceivable given the starry heavens we now gaze upon, but at one point, the cosmos was devoid of any stars, galaxies, or even light. The universe as we know it began 13.8 billion years ago with the Big Bang, an event that marked the birth of space, time, and all the matter in the universe. In the first 380,000 years after the Big Bang, the universe was an extremely hot and dense ionized plasma. The temperature and density were so high that protons and electrons could not form stable atoms. Instead, the universe was filled with free-floating particles, with light being unable to travel freely through this dense, hot soup of matter. However, as the universe began to cool, protons and electrons began to combine, forming neutral hydrogen atoms. This marked the beginning of what is referred to as the Dark Age of the universe, a period in which there were no stars or galaxies to light up the cosmos. During this time, the universe was essentially a transparent neutral space, filled with a dense fog of hydrogen gas. The universe remained in this dark, quiet state for millions of years, but eventually, things began to change. About 100 million years after the Big Bang, the first stars and galaxies began to form. These early cosmic objects gradually began to ionize the hydrogen gas in the universe. Their ultraviolet radiation separated electrons from protons, creating a process that filled the universe with free-floating particles once again. This process, known as the epoch of reionization, marked the end of the Dark Age and the start of a new era in the cosmos. It is sometimes referred to as the cosmic twilight, an era in which the universe began to transition from its state of darkness to the vibrant, star-filled cosmos that we see today. Despite the important role the epoch of reionization played in shaping the universe, it remains a period filled with many uncertainties and unanswered questions. But thanks to the James Webb Space Telescope, we are beginning to understand this era in ways that were previously unimaginable. The JWST was specifically designed for infrared astronomy, a technique that allows it to peer into the most distant and ancient parts of the universe. One of its primary missions is to study the early stages of the universe, specifically the time period immediately after the Dark Age. The results of this mission have been nothing short of astounding. In 2023, the James Webb Space Telescope made headlines by detecting 6 early galaxies that, according to the current models, should not have existed in the form they were observed. These galaxies, which were formed just 500 to 700 million years after the Big Bang, are already as massive as our Milky Way galaxy. This discovery is significant because, According to current cosmological models, galaxies that formed so early in the universe's history should be much smaller and less developed. These 6 galaxies contain more than 10 billion solar masses of stars, and in one case, the galaxy has more than 100 billion solar masses, a truly staggering figure. This raises a crucial question: how could such massive galaxies have formed so early in the universe's history, when there was so little matter available? To explain the existence of these galaxies, scientists must propose one of two possibilities. Either the density of matter in the young universe was much higher than previously thought, or the process by which galaxies formed in the early universe was entirely different from what we've imagined. In either case, these early massive galaxies represent a serious challenge to our current understanding of cosmology. As a result, these objects have come to be known as the universe breakers, structures that defy all expectations and challenge the very foundations of modern cosmology. But these 6 early galaxies are just the beginning. The discoveries made by Webb have only become more puzzling as scientists continue to analyze the data. One of the most intriguing finds was the detection of a galaxy named JWST 140, which appeared just 290 million years after the Big Bang. This galaxy is far too large and starry for such an early stage in the universe, and its size and brightness have led scientists to ask, how could it have formed so many stars in less than 300 million years? This is a fundamental question that scientists have yet to answer, and it underscores the extent to which the James Webb Space Telescope is challenging our understanding of galaxy formation and evolution. Before the launch of the Webb telescope, most experts believed that the early universe was filled with small, low-mass baby galaxies. This assumption made sense because our models suggested that there was simply not enough normal matter in the early universe to form large, massive galaxies so quickly. However, Webb's observations have revealed a very different picture. Early galaxies, like the ones discovered by the telescope, appear to be far more massive and developed than we ever thought possible for their age. But the surprises don't end there. Just a few weeks ago, Webb discovered a group of red monsters, galaxies that challenge everything we know about star formation and galaxy growth. These red monsters are not only massive but also highly prolific in terms of star formation. Their star formation rates are as high as 795 to 1,300 solar masses per year, which is far beyond what we would expect from a galaxy so early in the universe. To form stars at such a high rate, these galaxies must be converting gas into stars at a much higher rate than normal, and scientists are still trying to understand how they manage to achieve this efficiency. In fact, the red monsters have a conversion rate, the amount of gas they can turn into stars, that is 2 to 3 times higher than what we typically see in young galaxies. This discovery has profound implications for our understanding of how galaxies grow and evolve. It suggests that in the early universe, galaxy growth and star formation may have been far more efficient than we previously thought. However, scientists are still unsure about the exact mechanisms that allowed these red monsters to form so quickly and so efficiently. In the broader context of cosmology, these findings suggest that our models of early galaxy formation may need to be completely overhauled. The red monsters provide strong evidence that the early universe was far more efficient in terms of galaxy growth than we ever imagined. Yet, the exact reasons behind this increased efficiency remain a mystery, and scientists continue to search for answers. But Webb's discoveries are not just challenging our understanding of galaxy formation, they're also causing scientists to rethink some of the fundamental principles of cosmology. For instance, the expansion of the universe is happening at an accelerating rate, and this expansion is thought to be driven by dark energy, a mysterious force that is believed to counteract the effects of gravity. However, the exact rate at which the universe is expanding is still a matter of debate. The Hubble constant is a key measurement in determining the rate of expansion, and it has long been considered a cornerstone of our understanding of the universe. According to the Standard Model of Cosmology, the Hubble constant should be around 67 km per second per megaparsec. However, real-world observations, including those from the Hubble Space Telescope and the James Webb Space Telescope, suggest that the actual value of the Hubble constant is closer to 73 km per second per megaparsec. This discrepancy has sparked a heated debate among scientists, and it raises the question: could our current understanding of the universe be fundamentally flawed? A team of researchers, led by Adam Rees at Johns Hopkins University, used the James Webb Space Telescope to reanalyze the data from the Hubble Space Telescope in an attempt to solve this discrepancy. Their findings revealed that the value of the Hubble constant is closer to 72.6 km per second per megaparsec, which is still higher than the value predicted by the Standard Model. This raises the possibility that there is something missing from our understanding of the cosmos, perhaps an unknown factor that played a crucial role in the early universe's expansion. This issue could be related to dark energy, which may have properties that we don't fully understand, or it could point to the existence of exotic particles that we have yet to discover. Whatever the cause, the findings of the James Webb Space Telescope suggest that our current models of the universe are incomplete, and there is still much to learn about the true nature of the cosmos. In conclusion, the James Webb Space Telescope has revolutionized our understanding of the universe in ways that were previously unimaginable. The telescope's discoveries have forced us to confront the fact that our current models of the cosmos are incomplete and often incorrect. From early massive galaxies to the mysterious red monsters, the data from Webb is reshaping our understanding of galaxy formation, star formation, and the expansion of the universe. As scientists continue to analyze the telescope's data, it's clear that we are entering a new era of cosmological discovery, one that promises to challenge everything we thought we knew about the universe and its origins. Subscribe to our channel and thanks for watching.